When you make a drawing of a sheet metal part, it is essentially the same as any other drawing. You insert the views, annotations, and dimensions as needed to detail your part. There are some options, however, that will affect the appearance of flat patterns of sheet metal parts. Here I have a drawing with 3 views of a sheet metal part. What I'd like to do is add another view showing the flat pattern of this part. Before I add the view, let's take a look at the Options drop-down menu. On the Document Properties tab, there is a section specific to sheet metal. There are 2 main sections here. First, you see a listing of different items that will show up in a sheet metal flat pattern, along with a color setting for each. And to illustrate this, I'll change bends in the up direction to blue and bends in the down direction to red. On the lower part of the screen, I have the option of enabling the display of sheet metal bend notes. I'll check this option and use the above line style and click OK. Now let's focus on adding a flat pattern view into a sheet metal drawing. From the drawing toolbar, I'll select Model View. And from the Model View list, I'll select Flat Pattern. I'll click in the open area of my drawing sheet, and the view is added. You can see the bend lines are shown in red. If you remember, this is the color I set for bends in the down direction. Each bend line also has a note indicating the angle and direction of the bend. If you want to change the formatting of the bend note, you can access the settings in the Drawings View Property Manager. Just click on the Drawing View, and in the Property Manager, there is a section for bend notes. Here you can add items to the bend note using these buttons, or you can delete them from the box. If you want to hide the bend notes, uncheck the box next to bend notes, and to show them again, just check the box. If you've used bend notes before, you may have changed the note formatting with a text file, but all of the settings in the text file are also available here in the Drawings View Property Manager. One more way to hide bend notes is from the Feature Manager tree. Expand the view that corresponds to your flat pattern, and expand the Parts feature list. You will see the flat pattern feature at the bottom. Expand this feature, and hide the bend line sketch by right-clicking on it and selecting Hide. Note that if your bend lines have notes associated with them, the notes will be deleted when the bend lines are hidden. When working with sheet metal drawings, you can create a punch table so that you can quickly display information pertaining to form features and library features, just like you would with a hole table or weld table. Here, I have a sheet metal part with a bunch of forming tools used to punch out a few areas of the model. Before I go creating a drawing and adding a punch table, I'd like to show you something I find really helpful. It's how to add a punch ID to your forming tools. That way they're easier to identify in the punch table, and you can communicate which tools to use to your manufacturer. I'll browse for the form tool that I want to add the punch ID to in the design library, right-click it, and select Open. Next, with the form tool part file open, I'll go to File, Properties, and switch over to the Configuration-specific tab. Here's where I'll add the punch ID property. I'll choose Punch ID from the dropdown, leave the type as text, and enter the ID I wish to use. Now I can click OK, but I have to save the form tool in order to save the punch ID property. That's all there is to it. I find it's easy to just add the IDs to the form tools as you find yourself using them in your designs. But if you work with sheet metal a lot, you might want to take a bit of time and add the IDs to your library of form tools. Next, let's go ahead and add the punch table to a drawing. I'll switch back to the original sheet metal part and quickly make a drawing from this part. To insert a punch table, just as with other tables, you need to have a drawing view for it to reference. You have a flat pattern view to create a punch table, so I'll just drag it onto the drawing sheet from the View palette. Next, to add the punch table, I'll go to Insert, Tables, and choose Punch Table. The settings here are pretty much identical to those for a hole table, in case you've worked with those before. I have to specify the origin for the table and the faces of the model that contain the features I'd like to include in the table. The origin selection box is active, so I'll choose a vertex to locate the table origin. You can also use the X and Y axis selection boxes to adjust the coordinate directions. Next, I have to select an edge, face, or feature that contains the punches, so I'll select the face that I want to be used for the table. I'll leave the rest of the properties at their default values, click the green check, and now I can locate the punch table. Notice that the table shows the punch ID we entered earlier, X and Y locations, an angle, and a quantity. In a previous lesson, you saw how to create a SOLIDWORKS drawing of a sheet metal part. However, if you wanted to export your flattened part directly to DXF or DWG, SOLIDWORKS makes it easy to do. You can do this without even opening a 2D SOLIDWORKS drawing. It can be done directly from the 3D sheet metal part. To do this, I'll go to File, Save As, and I'll choose either DXF or DWG from the dropdown. I'll leave the default name and location for the saved file and click Save. This brings up the Export to DXF or DWG Property Manager. In the Export section, I'll leave Sheet Metal selected. I'll export the geometry, hidden lines, and bend lines, leave the rest of the options at the defaults, and click the green check. When I do, SOLIDWORKS opens the DXF DWG cleanup window. I can navigate around the preview within this window by using the View tools at the top. I can also select any entities that I don't want in the exported file and remove them using the Remove Entities button at the bottom. When the preview looks the way you like, click Save, and you have a DXF or DWG file out of your flat pattern. When you're creating drawings for sheet metal parts, you start the same way as you would any drawing. You insert drawing views, dimensions, and annotations to communicate the design with others. This includes adding dimensions for the inner bend radius, creating detail views to show corner treatments, and adding punch tables to give details about library and form features. Take this enclosure, for example. If you look at the feature manager, you can see it was created using 2 flange features, 2 form features, and 2 library features. In the drawing, I'll make sure to add the necessary drawing views and dimensions to create the part, and I'll use a punch table to annotate the library and form features. To get started, I'll expand the new icon and click Make Drawing from Part or Assembly. I'll select the sheet size A2 ISO, click OK, and make sure the units are set to mmgs, and scale to 1:2. From the View palette, I'll insert the front view and project out the top, right, and isometric views. I can't see the louvers from these views, so I'll also add the back view, which I'll project from the right view. Next, I'll change the display style of the front view to Shaded with Edges, and all the views update. First, I'll add the dimensions for the base flange feature. From the Annotation tab of the Command Manager, I'll click Model Items. Since I only want to dimension the base flange feature, I'll make sure the source is set to Selected Feature, and the Import Items into All Views checkbox is selected. To select the base flange, I'll click the flat face in the front view, and you can see all the dimensions are added. Let me clean up these dimensions a bit. I'll use the left mouse button to reposition the dimensions I want. And the right mouse button to hide the other dimensions. This looks good, so I'll click the green check, and the dimensions are added. Next, I'll add the edge flange dimensions. You can see that these features are difficult to make out, so I'll add 2 detail views. One in the front view, and the other in the right view. I'll also change the scale of both views to 2:1 to make them easier to read. Now I can add the dimensions using model items again, except this time I'll clear the Import Items into All Views checkbox. With the Destination Views group box active, I'll select the right edge flange in Detail A and use the left mouse button to reposition the dimensions. I'll click the green check, and the dimensions are added. The last 2 dimensions I'll add are the thickness and inner bend radius dimensions. This time, I'll use the Smart Dimension tool, and I'll add the dimensions in Detail B. I also want the material displayed in the title block. If I edit the sheet format and zoom in, you can see a note already exists that's linked to the part material. I want to keep this relationship intact so that if the part material ever changes, the note updates automatically. So to make the part material appear here, I'll have to create the property at the part document level. To do this, I'll exit Edit Sheet Format mode, open the part in its own window, and add the property to the document. I'll go to File, click Properties, and in the Custom tab, I'll create a new property. Using the drop-downs, I'll set the name to Material, type to Text, and link it to the SOLIDWORKS material. I'll click OK, and if I go back to the drawing, you can see the material now appears in the title block. To finish this drawing, I need to create a punch table. Notice I don't have enough room on this sheet, so I'll go ahead and create a new sheet by clicking the Add Sheet icon. I'll rename this new sheet Punch Table, and the first sheet Model Views. Before I create the punch table, let me add a note to the library and form features. I'll go to the Annotations tab of the Command Manager and click Note. I'll add the first note to the Countersink Emboss feature in the top view. I'll type, created using library and form features, see punch table for details. I'll quickly resize it and reposition it. I want to add this same note to the other three features, so I'll create other instances of this note by holding the Control key down on the keyboard as I drag the note, and I'll attach it to linear pattern in the front view. I'll do this one more time, attaching the note to the louver in the back view. Instead of creating a separate note for the D cutout, I'll simply create a second leader in this note by holding down the Control key and, with the note active, clicking and dragging the endpoint on the arrow. I'll attach it to the cutout, and no matter how I move the note, you can see it's always attached to both features. This sheet looks good, so I'll switch over to the second sheet. Before I can create the punch table, I need to insert a view to use as a reference, so I'll insert the flat pattern from the View palette and place it on the left side of the sheet. I'll make sure the bend notes are enabled, and the bend direction, angle, and radius are visible. In the flat pattern, I want to visually differentiate between the bend directions, so I'll change the color of the bends from the sheet metal document properties. I'll go to Options, Document Properties, Sheet Metal, and under Flat Pattern Colors, I'll set the bend lines up direction to red and the bend lines down direction to blue. I'll click OK, and the drawing updates. Next, to add the punch table, I'll go to the Annotation tab, expand the Tables icon, and click Punch Table. In the Property Manager, I'll use the default table template, enable Attach to Anchor Point, and set the alphanumerical control to ABC. To define the datum, I'll use an X and Y axis. I'll set the bottom horizontal edge as the X-axis and left vertical edge as the Y-axis. Under Features, I'll select the face of the flat pattern. I'll leave the border options at the default, click OK, and the punch table is created. I want to attach the punch table to the top right corner, but since I enabled Attach to Anchor Point, you can see I can't change the position of the table. Instead, I'll add an anchor point in the correct location. To do this, I'll go to the Feature Manager, and under Punch Table, I'll expand the sheet format. I'll right-click Punch Table Anchor, and click Set Anchor. I'll click the top right corner, and the table repositions itself, but it's still off the sheet. If I enable the table, you can see the top left corner is currently the stationary corner. I'll change this to top right, and the table is now contained in the sheet. Up to this point, I've created two drawing sheets. The model view sheet contains the drawing views and dimensions needed to create the general shape of the sheet metal part. And the punch table sheet contains the flat pattern of the part, along with a punch table, giving me information over the features created with library and form features. But if I zoom in on the table, you can see the punch IDs are missing. And if I go to the flat pattern, you can see the tags and bend notes look cluttered. First, let's focus on cleaning up the flat pattern drawing view. The first thing I'll do is increase the scale of this sheet. From the status bar, I'll expand the scale and select 1:1. I'll reposition the view until it looks good. Now if I zoom in, you can see tags A1 through A4 are the only ones that are still overlapping features. I could change the position of the tags manually, but I want there to be consistency with all the tags, so I'll change their position using the punch table document properties instead. I'll go to the document properties, expand tables, and click punch. In the tag angle offset from profile center section, I'll set the angle to 30 degrees and the offset to 12 millimeters. I'll click OK and rebuild to see the changes. Next, I'll add the punch IDs to the library and form features, which I have to do at the part level. I don't want to save the punch IDs with the actual library feature, so I'll add them to the features in the Feature Manager design tree instead. That way the IDs stay with this part and not in the design library. I'll add the punch ID to the countersink emboss first. I'll right-click the feature in the tree and select Feature Properties. Set the punch ID to C-Sync Emboss 12 and click OK. I'll repeat the same process for the rest of the features. I'll set the louver punch ID to louver 35, the D cutout punch ID to D sub 50, and the linear hole pattern punch ID to drill hole 10. It's important that you're careful when entering the punch ID for library features, because when you create the punch ID for these features, you won't be able to edit it again. If I bring up the properties of the D cutout, you can see the punch ID field is grayed out. But if I bring up the properties of one of the form tools, you can see that I can still edit this field. I'm done, so I'll rebuild the part and save it. Now when I return to the drawing, you can see the punch IDs in the table updated automatically. Let me quickly edit the column widths so that all the text fits in a single line. You can see that the punch ID is the same for several of these features, so I'll enable the table once again to combine the same types. In the Property Manager, under Scheme, you can see there are two options. Combine Same Tags combines items with the same punch IDs in a single row, while Combine Same Type merges the cells for punch features that have the same punch IDs. For this example, I'll check the Combine Same Types checkbox. Click the green check, and the drawing is done.